Yeah, great. Yeah, thanks, Kyle. Thanks, everyone. So I'm going to kick us off introducing the second, well, I don't know what agenda item we on. Are we on? About four or five or whatever, fourth or fifth agenda item um, related to pet data, like you were saying. So Josh brought, for anyone with a great OMUG memory, about a year ago, Josh brought a handful of new data elements to OMUG to share, and this was one of them. And so we're continuing that conversation around how that data is progressing and how we see it being used in models next. So Josh, if you want to move to the next slide. So agenda-wise, just talk a little bit about kind of the motivations behind starting to use this data more, what's going into the data, how we're going to use an activity-based models, then we'll open it up to questions. So go ahead, next slide. So as we've been developing as we've been moving towards the next set of travel demand models, our activity-based models, we've been having a metrics conversation around how can we improve the information that comes out of our tools. That metrics conversation has been framed up around the goal areas in the Oregon Transportation Plan, but those goal areas are very common across all of the regional transportation plans in the state. So very common themes: safety, equity, climate, mobility, community, economic, improving economic conditions, and preserving the system. So these are the goal areas in the Oregon Transportation Plan, and areas that we've been working to see what we can do to better improve the information that comes out of our models in each of these categories. So today we're focusing on the safety piece, and what our metrics conversation has kind of highlighted is that if we want to do a better job around safety, then we have to do a better job on understanding person miles traveled across all modes, and then for cars it's kind of a given what route they are on, but for biking and walking and our active modes, really understanding how many miles people are out there by the route that they're taking, so we can understand the exposure information, where individuals are, and what they're up against from the heavy vehicles that cause the safety issues. So yeah, thanks, Josh. So to summarize that point, our current models don't represent. I think Josh is trying to get the little graphic. I don't know why that graphic won't. He's got a really cool little climbing. Yeah, the little chart's supposed to climb. Sorry, Josh. It is cool when it happens. Let's see. So to summarize, our current models don't represent pedestrian traffic very well, and so the kind of a key objective here is to and it's hard to have our models estimate pedestrian travel if we don't have the data. So we have data now that is we can start to use, and so hopefully we can start to get better in representing our pedestrian travel, which we need to better capture safety metrics. In addition to getting better safety information out, there's also across the Oregon Transportation Plan, there's 3 specific focus areas: safety, equity, and climate. And so more broadly, this data can be used to from the safety perspective, like we kind of already captured. If we have this information, that we can better understand the risk exposure. So it's kind of clearly there as a safety piece, but also from an equity piece. Lower income populations walk more. So if we better understand pedestrian movement, we'll better capture the travel movement and behavior of lower income population. And then on a climate side, if we better understand active transportation modes and what influences them, we can better understand the outcomes on VMT and GHG production when different policies and projects around improving active modes are on the table. So these are all kind of the motivations behind why this data might be, or why we should be assembling it and then using it. So with that, Josh, I'll transition to you. If there's anything else you want to say on the motivations, go for it. But then we have the data piece here.
Yeah, no, that's great, Alex. Thanks. Hey, everybody. I know a lot of folks on the call, but my name is Josh Roll, and I'm a research coordinator with ODOT's research unit. And we've been working over the years on trying to better represent traffic flows for people walking and biking through our models, through our travel and traffic monitoring programs. We've helped a couple MPOs set up bike and pedestrian count programs. The first one in Eugene, Springfield area was to help validate the new bicycle route choice model that we adapted from research from Portland State and that the folks at Portland Metro had implemented. And so we've been working on this for years. Thankfully, the sort of state of the practice and things like the Federal Highways Traffic Monitoring Guide have advanced. The latest traffic monitoring guide has all the protocols and things that potential traffic count programs that would count bikes and peds would need to implement those programs. The challenge has just been resources. We're all under this incredibly fiscally constrained environment that makes doing something that the feds don't require, the state doesn't require, almost impossible. But that context aside, we've still continued to try and find ways to better monitor the system for those non-motorized modes, those active modes, using available infrastructure if possible. So one of the projects that I've come to this group and others to talk about over the last probably year or so is a project where we had a research team from Portland State and Utah State University develop some methods to take our push button data at traffic signals and turn those into estimates of pedestrian volume. This was building on work that Utah DOT had done pre-pandemic. And so we had kicked off this project just during the pandemic, I think late 2020, early 2021. And that's relevant for some transferability of some of the methods from Utah, which I'll talk about I guess here on this slide. But the report has been finished. That work has been done. There's a full technical report on our website. I'll also have a link at the end to a video of Sarisha Katuri, who led that work from PSU side, presenting at a PSU Friday seminar. But the essence, right, is that people go to a signal to cross, oftentimes pushing a push button. And when you correlate those or relate those to actual counts of the people using the system, there's a pretty strong relationship. It's not one-to-one. You got to do some things to the push buttons to filter out all of the anxious elbow pushes as people sit there waiting, thinking that the more times you push it, the faster the light will turn for you. So there's some filtering work that was tested, some filtering methods that were tested, and then a bunch of different model specs that were tested, which I'll talk about. But again, the essence is taking those push buttons, which we have at least on ODOT signal system at almost 700 locations, growing every day. We'll have up to like 1,000 of we have about 1,000 signals we manage. There's some problems going on with a transition to the backend database that stores these data, but at some point we'll have 1,000 locations collecting these data. Mostly good data. I mean, there's still buttons that stick and hardware issues and stuff that you got to filter out like any traffic count device, but good data in a lot of places. Coupled with the data from local jurisdictions, for instance, PBOT is also working on getting all these data integrated. We'll have like 2,000 traffic signals feeding these data. And if we think of them as permanent pedestrian counters, having 2,000 on-street pedestrian counters so far surpasses my wildest dreams of the number of devices we would have monitoring peds of what I would have thought about 5 years ago. So it's a pretty incredible set of data. Still some work to get it all integrated, but But the work we had the team at Utah State and Portland State do was go out. We collected about 900 hours of observed data, interfaced that with the push buttons at those locations, tested a couple different ways of counting the push buttons. There's different phases that you can count in the signal controller. That's this like A45, A45A. These are also different ways of filtering the data. Do you start filtering after or do you stop counting for 10 seconds or 5 seconds or 15 milliseconds? So we tested all those. That's what these A, B, C different configurations are. Different model specs, so linear, piecewise, quadratic. And then we have performance measures here, just raw correlation of the counts and the signals, counts being the observed empirical data, RMSE, mean average error, and a couple different ways of looking at that. And then also doing this like using like a holdout approach where you take part of your data, estimate a model, and then try to predict your fold that you left out. And what we landed on was the quadratic, which was the same as what they found in Utah. And I'll just mention a bit about the Utah research. Utah has traffic cameras at most of their intersections. And so we're accessible for the work that was done there. And they, from those video, gleaned the number of actual pedestrians, the empirical counts, and they used something like 10,000 hours of data to sort of build their model. And let's see. And one of the things that the research that Oregon did, that I coordinated here, was like test their models using our data and vice versa, and the results were remarkably similar, which showed that both there's spatial transferability of these methods, but also temporal transferability, especially given that that work in Utah was pre-pandemic. And ours was post-pandemic, and whether or not people are a little more hesitant to touch buttons and that sort of thing. So a lot of promising results from the work that was done, and now we're moving into implementation. And so I'll share the link to this very simple dashboard that I crafted here at the end. But we have these data up, factored. We have them for multiple years. You can cruise around on this dashboard. We have another one that Sean Strasser, one of our very data savvy signals guy, had put together. I can't find the one that's like public facing. I got the one that's for internal use, but ultimately, oh, do we have a question? Somebody stepped on a cat. Okay. Ultimately, these data are going to go into the BikePed data portal at Portland State. So we've been working with the portal group there. We have some funding together, so everything will be wrapped into that platform, hopefully in the next 6 months. We're working with them, trying to get the data pipeline set up. And then there's still some anomaly detection work that we need to do that I mentioned when buttons stick, or other strange things that happen. But we're already looking to use these data in the purpose that Alex mentioned, that he'll get into a little bit more next. But also in some of the work we're doing on building predictive crash models for PEDs. We have all the data constructed for that, which I'll talk about in the next presentation. But for now, I'll turn it back to Alex. He can talk about the model calibration that we're planning.
Yeah. So on the model side, I think for a long time, I think our travel models have had an autofocus, but also there's we've had the easy out in that there's not a whole lot of data available. So, even if we wanted to do a great job with PEDs and bikes, we don't really know how they're moving around. Well, sorry, say PEDs this way, active transportation, but PEDs in this particular case, if we want to do a good job understanding where PEDs, how PEDs move around the system, well, we didn't really have the data to QC it or develop it. So we didn't have an egg to raise a chicken, but now we have the egg. So we can have chickens. So if you go to the next slide, Josh. So now that we have chickens, so now the next step is we have at least 5 steps. I'm sure we could daydream more here, but the first thing we need to do, we have I think most of our MPO travel models have pedestrian ODs. We just don't assign them. At least I'm not aware of us assigning them to the network, putting them on routes. So step one, let's assign them to the routes and see what happens, probably using a shortest path or something similar. We now have the observed data that we've never had before, so we can start to QC those assignments against observed data and see, I imagine we're going to be pretty off in some places because shortest path won't consider how terrifying it is to cross a certain intersection, and that most people would deviate out of the way of that intersection. Our models also, I'll get to this in a second, but our models also don't have what I believe is probably a really large percentage of pedestrian trips, which are loop trips, trips that you make, just to get exercise or walk the dog. Those aren't in, so we probably also are going to have an issue with those, kind of recreational or optional trips or loop trips or whatever you want to call them. So we're going to have some some issues, and that I think that step 3 will be where we start to determine what's different and why do we think it's different. Luckily for us, in 2025 we're entering an estimation phase, so this times out well. If we see some differences and we think we can correct for them, we can start to bring in additional network attribution, like some kind of quality metrics. We've talked about research elements to better represent loop trips. We can start to bring some of these pieces in to try and close some of these gaps that we identify in step 3, and then if we determine that that if we're able to better pull in the information that helps explain where people are traveling, then we can finalize these new models with the network inventory and attribution that gives the models the explanatory power we need to understand where PEDs are how PEDs are using the system. So then in the end, we'll have improved model representation of pedestrians using the systems, and therefore we'll have the safety metrics and estimates that we need to be faithful to the desire to improve our safety metrics. So then, Josh, if you move to the next slide, this is just conceptual. I had hoped that maybe we could have had something a little bit more concrete to share here about what does step 1 and step 2 look like. Of step 1, assigning our current pedestrian flows and then assessing where we're at. I believe shortly after some kind of OMC meeting, we could bring that comparison back for some of our models. But basically, this is what it looks like. The pedestrian information that we have right now, for various reasons, we could definitely answer in a Q&A if we want to. It's an intersection number, not a crossing number, and so we would have to total up our model, the amount of pedestrian movement moving through a node, and we would total up pedestrian movements at a node. We would then compare it to the amount of pedestrian movements moving through an intersection / node that we're getting from the actuation data, and we could start to do some scatter plots and spatial mapping to see where we're low, where we're high, things like that. So that's what step 1 and step 2 would look like. This is just kind of comparing that we have 2 spots in a map and that you can pull this information, but we need to do it kind of globally and understand it so that we can bring step 1 and 2 back to this group later. And then when we move into step 3 and step 4, we have this great new survey that's going to have a ton of great information. So unlike surveys in the past, we'll have more detailed route choice representation specifically for active modes, which we've never had before. We're going to have this current survey went much farther in properly capturing all Oregonians of all types from an equity focused standpoint. So we'll have a much better canvassing of the types of Oregonians using the system. And we'll also have a better, so a lot of this survey is cell phone based. The paper surveys of the past had the potential or the issue of trips being skipped if they didn't seem important or too small. And so now we have apps that were tracking where individuals moved. And so we're going to have a more complete representation of all of these little trips that were happening, all of the uses of the system, the different modes that were being used. So we're going to have a ton of great information with the survey that can help improve our abilities to represent all travelers. work is still required. The survey doesn't quite answer everything, so we have to supplement and augment that survey. We need the networks behind the survey, and we need the inventory data on those networks that represent quality for the quality of the path for biking and walking. So that's going to require some inventory work. Luckily, the state is pushing forward a pretty hefty contract right now to do a lot of inventory work. Hopefully the bulk of that lift in our MPO regions across the state. So hopefully we have somewhat of an easy-ish answer there. Let's see, like I mentioned earlier, there's also, when it comes to pedestrian movement, some additional research needed around, loop trips that are missing in our models, weekend movement, visitor movement. I'm not saying that we have to do all this, but this is just places where we would, if we really wanted to understand pedestrian movement, we might need to close some further gaps there that the survey, the survey would cover weekends. Our models don't cover weekends, doesn't cover visitors. So there's just some pieces there. And then, what was my last point? Motivations, mode choice, being understood. I think it's just, kind of getting at that missing inventory data around, is it like, what kind of trip is it? Is it is it a choice trip, or I guess I was thinking about captive trips. Like, am I walking because I want to get the exercise and I have a car at home, or am I walking because my auto ownership is 0 and this is my best way to get there? So understanding kind of how people make choices under different conditions and different availability of options. And then also, I was listing here the last bullet. There might be gender preferences from personal safety issues. Men be more likely to bike. I think, see, the survey says I think men are more likely to walk in different situations than women would be. So anyways, things that we would need to tease out there. So as I list all of that, I meant to mention, as I looked at all of that, you could very well be thinking, well, Alex, I don't agree with that bullet, or where's this bullet? And so that's the next slide. Yeah, go ahead, Josh. So we're done talking. We're curious from this group of that bullet list that I just sent. Are there other research things that you pop to mind? We're getting close to the research cycle. There's a lot that needs to be done here. So we're very curious what other ideas there are around how to fill these gaps. And what the gaps you anticipate are. We're also, as Josh and I were working this, it kind of became evident that this signal data that's being used is across all days. I think you're saying 20 minutes, Josh. Is that what you're saying? 20-minute bins. So highly temporally detailed, and for modeling work, that's super overkill. So, curious, how would you, how are you interested in using this data? What data format would you like it in? What time periods would be helpful? I've started talking with Josh, thinking about kind of a Wednesday in May, hour bins probably, those kinds of things. Ultimately, maybe we're looking at weekends for some future research. It's all there, but kind of initially, what formats, what aggregations would you be interested in? There's a final slide about some of the resources that Josh mentioned, but before we move there, I think we're opening it up to questions, and I'm done talking.
Yeah, and just
thanks, guys.
Sorry, Kyle, and just to emphasize, one of the asks here is just about, or two of them rather, is just about what are those questions that need somewhat of a full research effort to uncover. We have the research program here at ODOT preparing in the fall to start writing research proposals that would come to our office and be considered for funding. And then the second piece is, what are the metrics specifically within the push button derived PED volume estimates that are necessary for you and any of the work you're doing in planning or modeling, so that we can build that type of functionality into the user interface of the Bike Ped data portal or the Our Shiny app or whatever, that will be a short-term solution, that Our Shiny app, but the Bike Ped portal being a longer-term one, and folks that can do something probably more sophisticated than what I can do in Our Shiny. So those are two specific asks along with those bullets. So
So, in terms of these questions, Josh and Alex, if people do have ideas, they would just get a hold of you guys via email, or what's the best way to, I guess, address these questions if people want to follow up with you on this?
Well, I personally assumed everyone would be exactly ready right now to answer these questions, and we would just deal with it now. But I think email would be great if people want to react to this.
Okay, maybe you guys could put your email addresses in the chat box. Quick question for Carol, just doing a time check here. How much time do we have for Q&A on this particular topip?
Yeah, we're good. We have another 10 minutes if there's questions. Yeah.
Great. Do you want to, Carol, do you want to scroll through the chat box and see? It looks like maybe Ray had a question that's going to be maybe pertinent to our data fusion topic that comes up next.
Yeah, Ray has a couple questions in there.
Yeah, I'm happy to take them. Yeah, Ray, we're going to talk about next how to fuse multiple data sources and train models on these push buttons, in addition to some other data, which we haven't fully compiled yet, in order to estimate pedestrian volumes at locations where we don't have counts. So we'll talk a little bit about that, in addition to an evaluation of a third-party data product from Replica that also has estimates of ped volumes. So so the short answer is we're going to use these data to estimate in those locations where we don't have data. We'll also be bringing in some short duration counts. So that's an ask I have of folks of like, hey, what do you got for short duration counts? Ideally 16 hours or more. But and then in terms of signal controllers, the latest ATCs are the ones that ODOT's been installing and that have the capability of storing these data and housing them somewhere. So that's the big rub. I know that ODOT struggled, at least initially, in storing the data, that the state data center at first was like, sure, give us all the phases. But it turns out it's a ton of data, and they began squawking soon after we were doing the transition, maybe a year and a half ago. And so we have since had to come up with a different plan, including aggregating some of the data. And so instead of collecting every phase, things are collected in 15-minute bins, which created some problems because we needed the filtering method to be applied to the raw data before it got aggregated. And so some things to work through there. But hopefully that answers your questions. I'm curious on what Salem and Salem-Kaiser area signals look like, because the more signals signal folks we can get thinking about this as they're selecting technology and back-end databases, the better the capability will be over time for using those data for this purpose.
Yeah, just on that, I know Salem's moved to 2070s and some of the newer adaptives. And we have had conversations with Salem, and maybe you, I don't remember, about capturing that data from the push buttons. Also, right. The RFBs used to collect the data, and then they got bought, and so that data is you either have to pay a subscription to get to it, or it's no longer available from the vendor, which would be another good one. Mid-block.
Totally.
Would be very useful.
Yeah, that's right. I remember that conversation now, and if I remember, the data's available, but there's no centralized database that the data are flowing to. So you would need somebody to go out to each controller and collect the data. And,
right.
That's been something that's prevented us from considering this approach before because of that need. And so that's been another motivation for moving towards this approach for monitoring PEDs, is because all these data are being stored centrally, making the data accessible.
And it might also be the controller software, not necessarily the controller, because I know ODOT and Salem run two different programs, and they might just deal with collecting the data differently. And so each jurisdiction, you'd have to ask, what's your controller and what sort of software are you using, and does it collect it and store it, et cetera.
Right.
Okay. Let's see. Any other questions from the group to either Alex or Josh?
Kyle, I got a question.
Sure.
Well, I don't know.
Jeff?
Actually, I'm not sure it's a question, but it's research I would like to see pursued or not pursued. The first thing I want to say is I hope the fact that these push buttons are a valuable data source doesn't induce ODOT to install more push buttons, and that the push buttons will only be installed in locations where they're necessary. And that kind of leads into my interest in or research I would like to see pursued is looking at the variation between the ratio of crossings to push button pushes, and looking at what are the characteristics of locations where that ratio is high or low, and specifically thinking about the locations where the ratio is high, that a lot of people are crossing without using the button. It's probably a location where the push button is either not necessary or counterproductive, or some other intervention would need to be pursued to figure out why people aren't using the push button. Any thoughts about that?
But I would just say I don't think ODOT's modeling work has anything to do with how ODOT makes decisions on push button placements. I would just, perhaps if that adds any comfort. Go ahead, Josh.
Yeah. Well, lots of interesting questions, Jeff. I think what we need to do for this method to keep working is to continue to, like, every couple years do additional data collection and comparison and see how the factors are working. I think there are going to be conditions where we don't pick it up well, like the total volume, because of big groups or, conditions that just aren't the average. And it kind of gets into a question about how good is good enough that, we talk a lot about with some of these methods for estimating bike and walk volumes, where because the numbers are so low in a lot of cases. I mean, you'll see in our Shiny app that I'll put out here, like, there are places where, based on these methods, we're looking at just a few a day on sort of the annual average, a few PEDs a day. And a lot of those are just like around really inhospitable places where you wouldn't expect a lot of activity. And so if you're now, using those data, and if you're off by 100% or even 1,000%, like, does it matter that it's 20 and not 2? So there's questions like that get into, I think, testing the data in different applications. I mentioned we're going through with putting these into safety performance functions to see how that they work, and whether or not the uncertainty in the estimate, how much uncertainty matters. In terms of not installing these, I hear them called beg buttons. I think, Ray, you just said that too. And I am in my mindset, I always follow this sort of like PBOT, Portland Bureau of Transportation's hierarchy of users, where it's certainly PEDs first, bike second, transit, and so on. And I think in order for us to meet any of our safety, climate, and equity goals, we have to adhere to that framework. And I know that ODOT being a manager of highways, we don't always necessarily do that, especially historically. But I'm not sure I agree with the term beg button there are certainly more advanced ways to give pedestrians preference. But for now, with like arterials, I don't know what else. I mean, again, barring cool advanced, computer vision technology or LiDAR or something, I feel like these are good systems, and especially if they have responsiveness where after you push it, you don't wait another 3 minutes and you're waiting, 15 seconds or less. That's great, right? But whether or not any of the demand on the data would inform where we put signals and push buttons, we're probably not that well organized. So I don't think that's going to happen. hopefully that answers some of your questions, Jeff. But happy to talk more, especially about any of the research ideas that might be bouncing around your brain.
Are all these locations at intersections where the vehicles are also, stopping on a regular basis, or any of them mid-block, like pedestrian?
Yeah, they're all intersections, no RFBs, unfortunately. And there's, we'll talk about this in the next presentation here, just about how well we can estimate at non-signalized locations, which may have a, induced demand sort of effect for PEDs, estimating at non-signalized locations and how well that's going to work, and how we'll test and validate how well that works. Because that's certainly a question.
Hey, Josh, for the data, did they consider location of bus stops in relation to the intersection, and then see if there's APC data from the transit vehicle to see if there's a correlation between?
Sure.
Yeah.
Well, when the research team that built the factor methods for the push button data tried doing that in different sort of clusters and buckets. We tried like place types. We did some different buckets by like proximity to transit stops. And the one using place types did actually work a little better in terms of some of the performance measures. But we felt like it was maybe the performance gain wasn't worth the complications of applying them. So we went away from it. But in terms of then general sort of, correlation of or relationship between PED volumes and transit stops, are shown in the next presentation, how that is definitely a useful measure. We have great data on transit stops. We don't have great data statewide on transit ridership. So we have some data in some places. That's another project that we did many years ago, was building a data standard for transit ridership at the stop level that interfaced with GTFS. We call it GTFS Ride. We would love to see more transit agencies get on that standard, so I'll put a plug-in for that, so that those data can be uniformly collected across the state and used for things like this, among other uses. But definitely a relationship that we know exists and that we're trying to test out with the data fusion work.